When expanding and condensing logarithms, there are three log properties that are going to be the most useful to us. The first is if we have a logarithm with two items in the argument that are being multiplied together, we can split that up into two separate logarithms, each getting the same base as the original logarithm. And those separate logarithms are going to have the operation of addition in between. So multiply on the inside means adding when we split them up. The second log property is if I have a division inside the argument of a single logarithm, I can split that up into two separate logarithms, again, each getting the same base as the original. This time in between there's going to be subtraction. So division on the inside means subtraction when we split it up. The third log property that's going to be helpful to us here is the one that allows us to take an exponent within the argument of the logarithm and move it out in front as a coefficient. So whenever we see the word expand, we want to stretch this out into as many separate logarithmic expressions as possible. So in taking a look at number 6, I see two items inside of this argument. I see the 16 being multiplied by the x squared. So each of those is going to get its own logarithm. Since they are being multiplied together on the inside, they're going to be added together once we separate them. Both are going to have the same base as the original, base 4. Next, I'm going to bring down any exponents out in front, becoming a coefficient. So this will be log base 4 of x times 2. And I also want to evaluate whenever possible. If I don't have any variables, like in log base 4 of 16, I'm going to evaluate that. Log base 4 of 16 is 2. So my final expression is going to be 2 plus 2 times log base 4 of x. Taking a look at number 7 now, similar in that we are trying to expand this logarithm. A little bit different in that on the inside of this logarithm we now have division, so I'm going to have two separate logarithms. Once I split it up, this time those separate logarithms are going to be subtracted. The other thing I have to be careful about is that they both are going to have this original coefficient of 2. So I'm going to keep that 2 on the outside, and I'm going to split up the argument of that single logarithm. Both are going to be the natural log, same base e as the original. I'm going to distribute this coefficient of 2 in here, so I get 2 natural log of x to the 7th power minus 2 natural log of z cubed. The last step is to take these exponents and bring them out in front as additional coefficients. So I'm going to multiply 7 times 2 to give me 14 times the natural log of x. Negative 2 times 3 gives me a negative 6 times the natural log of z. And this is my final expanded expression. Nothing to evaluate since both of these expressions have variables in the argument. The last problem on this section is going to be in the reverse direction, so condensing the logarithm. We can combine these three terms since they all have the same base, log base 2. Anywhere I see a subtraction sign, I know that the term after it is going to go into the denominator of the single condensed logarithms. You could also think about taking out a GCF of -1 from the second and the third terms here in this expression, which would make that 5 log base 2 of y plus 4 log base 2 of z. And so you can see that these two terms are going to be multiplied together, but then they're going to go into the denominator because of that minus sign. Before we can get there though, I'm going to take any coefficient and move it back in to the argument. So I get log base 2 of x squared minus log base 2 of y to the 5th plus log base 2 of z to the 4th power. Now I'm going to go ahead and combine the second and the third terms. Those are going to get multiplied together because of that plus sign in between. So I get y to the 5th times z to the 4th power. combining that with the first term, because of that subtraction sign again, we're going to get division in the condensed logarithm. So I get log base 2 of x squared divided by y to the 5th power times z to the 4th power. And that is my final expression.